we're going to go ahead and look at another example for solving multi-step when we have those three different types of solutions, right? So we could have x equals something, we could have no solution, or infinitely many solutions. So we're going to go quick here. So we'll draw our line through our equal sign, separating our equation out. And then we're going to color code. We'll have variables in one color. Variables are always going to be on the on the left, and constants are going to be over here on the right. So V and a C. All right, looking at this problem, we can see that we've got some parentheses. So we want to go ahead and start by simplifying. We'll distribute that out. So we'll have negative 3V, and that would be minus 12 equals 2V minus 37. All right, and then we're just color coding. We'll circle or highlight the variables in one color and then our constants in the other color. All right, so this is just reminding us we want variables on one side, constants on the other. So it looks like we're gonna have to move some things around here. So we can start by moving the variable. We'll move this 2V over to the other side. And in this same step, I'm also gonna move this constant 12 to the other side. All right, so simplifying, we'll have negative 5V is equal to, right, we do a quick check of negative 37 plus 12 should give us negative 25. All right, now it looks a little easier, right? One-step equation. Our goal is to get V by itself. We see this negative 5 is preventing us from doing that. We want to get rid of the coefficient. How do we undo, right? Multiplication, division. So we're going to divide both sides by negative 5. Negative 25 divided by negative 5 is going to give us an answer of positive 5. So V equals positive 5. All right, we're going to look at the three different types of solutions. Another example for this video. So give me a moment to clear this. All right, and we'll go to our next example. All right, so same idea here. We want to start by drawing our line through our equal sign. And again, we're observing there are some parentheses here for parenthesis k minus 8. So we want to get rid of, we want to simplify, right, getting rid of those parentheses. So how do we do that? We're going to distribute yet again and rewrite. So I'll have 4, in this case, variable is k, minus 8 times 4 should be 32, equals negative 32 plus 4k. All right, and then same idea as before. If I can write that correctly. Oop, it won't let me erase. Okay, variables on this side, and then constants on the other. Beautiful. Some of my best handwriting right here. We're going to go ahead and color code our variables, and I'm just going to show that step of moving this guy over. Minus 4k. That one moves over. We'll also move the 32, add 32, cancels. All right, and then let's simplify and see what we're working with. So 4k minus 4k. Again, if it's a little tricky with the variables, I like to think of it as like an example, like an object like cookies. 4 cookies, take away 4 cookies. I know it's kind of silly, but they're going to cancel and leave us with nothing on the left. Looking at the right side of the equation, we've got negative 32 plus 32. Same idea. They're going to cancel. They're gone. So 0 equals 0. So anytime our variable is gone, it cancels. We're asking ourselves, does this make sense? Is this a true statement? So remember, we're asking ourselves, is this a true statement? Right? So does 0 equal 0? We're thinking about it. Yeah, 0 equals 0. That's the same thing. They're equal. So in this case, yes, it's a true statement. True statement. Which means we have all real numbers or infinitely many solutions. So either one. Infinitely many solutions or we can say all real numbers. They both are saying the same thing, so it doesn't really matter which one you choose. All right, so again, was this a true statement? Yes or no? If it is, infinitely many solutions. So infinitely many, that's what we're using for our class. And that's it. That's our answer. Infinitely many for this one. All right, remember there are 3 different types of examples. We're going to look at our last one. Give me a moment to clear this out. All right, we're going to look at the next one, our last one for this video. All right, same steps. We're going to draw our line through the equal sign. We're going to get it all set up. We want variables on one side, and we want our constants on the other. Variables on one side, constants on the other. All right, we're looking at this, and again, there are parentheses we need to distribute. This one's a little weird because it's just a negative sign, and I know some of us from class, we could notice. Another way to get rid of that is by dividing it from both sides. You absolutely can do that. You can divide both sides of the equation by -1 to get rid of it on the left and change the signs of everything on the right. It will get you the same answer. But for the sake of our class being consistent with our steps, we're going to stick with that one method, just keep it simple. But I want to point out, in math, there's a lot of different ways to solve and you get the same answer. So if you have another method you prefer, that's fine, we can use it. All right, we distribute. What is that doing when we're distributing a -1? Distributing this negative, it's just going to change the sign of each of those terms. So we'll have -3, -3, and then now instead of a negative, positive, 6b equals 6b plus 5. All right, so we cleaned it up. It's looking a little neater, a little easier for us to manage here. We're going to highlight or circle all of the variables in one color, same steps as before, and we're going to highlight or circle the constants in another color, just reminding ourselves, keeping it organized. We want variables on one side, constants on the other. So we're going to be moving some stuff around here. We're going to move this 6b to this side. And then we'll also add 3. All right, clean this up. 6b minus 6b, and if it's a little tricky, think about it in terms of like food or an object, right? 6 cookies, take away 6 cookies. They're gone, they cancel, leaves us with 0. And let's see, 5 plus 3 is going to be 8. And again, same idea as before. We're asking ourselves, is this a true statement? Is this a true statement? What do we think? Does 0 equal 3? Excuse me, 8. That's not a 3. Does 0 equal 8? Right? And I know for some of us it's a little tricky. Thinking about it too, like with money, if your balance is at $0 versus $8, is that saying the same thing? Right? No, it's not a trick question. No, they're not the same number. So when they do not equal, when it's not the same, we draw a little slash through the equal sign, telling us it is not equal. They're not equal. So in this case, no, it is a false statement. False statement. What does that mean if we have a false statement? It means our answer is no solution. It means no matter what we plug into x, it's not going to work. I forgot to mention this in the last one for infinitely many. Remember, as we learned in class, that just means any number we're plugging in for x would work, but in this case, it's never going to work. There's no solution. Nothing will work because 0 is never going to equal 8. All right, or just when we canceled out the variables, we had -3 equals 5, right? That also doesn't work. So no solution, we box. That's our final answer for this one. As always, if you guys have questions, make sure to email, text, let me know. Hopefully this video helped with our homework and getting ready for our quizzes and exams. All right, take care. Bye.